nice quick little one here. Going to run you through an explanation of what a mathematical identity is. So whenever you see this little 3 bar equals sign, you are dealing with an identity. But before we get there, let's take another look at equations. So equations tell us that the thing on the left is equal to the thing on the right. However, they are only true for some particular values. So if you look at this first one, x equals 5. Anybody that's played even the most basic of algebra will probably know that we see x equal a lot of different numbers. Fact is, x can equal any number that we set it to. So we could just as easily say that x is equal to 4. We could say that x is equal to minus 1. There is no unique value that x can be set to. Or if we've got 2x plus 8 equals 4, if we solve that, we would have 2x equals minus 4, and then divide by 2. So that's actually telling us that x is equal to minus 2. So that equation, 2x plus 8 equals 4, is only true when x is equal to minus 2. If we substitute in x equals 3, we get 2 times 3, which is 6, add the 8, which is 14, which is not equal to 4. So that equation only works when x is equal to minus 2. If we look at this chap on the right, y equals 4x minus 5, that will only work for certain values of y and x. It won't always be true. So let's say we substitute in here x equals 1 and y equals 2, then we would be saying that 2 is equal to 4 times 1 minus 5, which isn't right. So there will be values that satisfy that equation, but it's not true for every value. We've just shown that. P equals 6q. Again, this will only work for certain values. So this is saying that P is 6 times bigger than Q. So for example, if we had Q equals 1, we would get 6 times 1 is equal to 6. So Q being equal to 1 satisfies that equation if P is equal to 6. However, if we substituted in P equals 5, then we would get 5 is equal to 6. That's not true. So that is only an equation because it only works for some values of P and Q. Same again down here with A minus B equals 9. That would work if A was equal to 10 and B was equal to 1. 10 minus 1 is indeed equal to 9. Now there would be loads more combinations that we can substitute into that to make it work, but it's not true for every single value that we set A and B. That brings us to identities then, the whole point of this video. So a mathematical identity is something that is always true without exception. So for example, on the left, x plus x is always equal to 2x. So let's have a look. If we set x equal to 1, we would have 1 plus 1 is equal to 2 times 1. That's saying 2 is equal to 2, and 2 definitely does equal 2. Let's say we shoved in minus 5, we get minus 5 plus minus 5 equals 2 times minus 5, which is telling us minus 10 is equal to minus 10. So no matter what value you shove into x plus x, you always get 2x. So that's our first identity for this video. Same in the middle as well. If we do x times x, that will always give us x squared without exception again. So again, let's go for 2 times 2 is equal to 2 squared. Absolutely true. 4 is equal to 4. Minus 1 times minus 1 will equal minus 1 squared. Minus 1 times minus 1 is positive 1. Minus 1 squared is 1. So that's another identity. X times x will always equal x squared for every single value that you substitute into it. A plus b will always equal b plus a. So if we set a equal to 1 and b equal to 2, we would get 1 plus 2 is equal to 2 plus 1. 3 is equal to 3. So no matter what values there we substitute in for a and b, that will always be true. So those three are 3 examples of mathematical identities. And to finish off, we're going to take out 3 pretty famous ones. So this top chap then, x plus a times x plus b. Hopefully that looks familiar. It's a quadratic expansion. Now when it's purely algebraic like that, you will always get x squared plus a plus b, lots of x, plus ab at the end. No matter what values of a and b you substitute in, you will always get that answer. The second one, another quadratic expansion, and quite an important one to be aware of, the difference of 2 squares. So if you multiply a plus b by a minus b, you always get a squared minus b squared. Again, for any value that you substitute in, that will always be true. And then our final chap down here, the definition of the tan function, tan of theta is always equal to sine theta over cos theta. That's the definition of the tan function. Very important trigonometry identity, and that's identities, guys. Was this video helpful? If so, be sure to leave a thumbs up and a comment telling me how you get on. For any further information, you can follow me on Facebook and Twitter, and send requests or any feedback you have. Search for Maths with Mouth. Cheers, guys.